Hello, it's my great pleasure to present our MSBD 5012 group project, Sentiment Analysis on Women's E-commerce Clothing Reviews. This is the outline of today's presentation. There are 7 sections. Alright, let's get started. The first section, Introduction. This project is about online shopping. As we know, the competition of online shopping market now is fierce. In order to provide better products and services, many online retailers need to analyze the feedbacks and comments of their customers. Such analysis in the past was very time-consuming. However, now with the development with machine learning, the analysis can be made in a very timely fashion. In this project, we apply the knowledge learned in the machine learning class to analyze the sentiments from customer comments. Section 2. Data. The dataset is obtained from Kaggle, and it has 10 feature variables. However, not all these feature variables are useful. Only text features and sentiment features are used. So the feature we're going to use are title, review text, rating, recommended IND. Let's do a data exploration together. As we can see here, the data set looks reasonable except for a small problem. There are 16 comments with the lowest rating, but still being recommended. We believe this trivial problem won't affect the reliability of the data. Let's continue the data exploration. There are 2 parts in the sentimental feature, recommended and rating. For recommended part, we use 1 as a label of recommended and 0 as not recommended. This is the distribution of it. For rating part, we label the ratings of 1 and 2 as negative, 3 as neutral, and 4 and 5 as positive. This is the distribution of it. As we can see here, over 80% of the data is tagged as recommended. Therefore, the data is imbalanced. We'll offer the solution to it in section 4. Let's continue the data exploration for the text feature part. Here are some interesting facts. Words like love, flighter, and great are often in recommended comments. Small, return, and huge are often in not recommended comments. Section 3. Text Preprocessing. Before we apply machine learning and deep learning models to the text features, we need to do some pre-processing work. The reason for this is because there are many meaningless characters in the comments. Removing such characters and reorganizing the sentences can help the further research. So the first step is merging text features. We merge the features title and review text into a new feature, review. The second step is removing all numbers, such as weight, size, etc. The third one is removing stop words. What are stop words? In English, some words in a sentence do not have real meaning, such as the articles, the, the, and a. In NLP, we name these words as stop words, and they should be removed before building models. We use the Python library toolkit to achieve this. And then, we need to collect all the adjectives and verbs. In English, adjectives and verbs can reflect the sentiments of sentence mostly. We use an NLP library, NLTK, to identify the parts of speech of the words in a sentence, and only keep the adjectives and verbs. And then we need to do stemming. Stemming is a process of removing the prefix and suffix from a word and only keep its root. We use a stem algorithm, Porter-Stemmer, to do this. Section 4. Sentiment Analysis with Traditional Machine Learning Models. Before we use machine learning models to the dataset, in order to reduce the effect of the imbalanced data problem mentioned in Section 2, we need to use some special ways to measure the performance of the models instead of just accuracy. So the first one is F1 microscore, which is a harmonic mean of precision and recall and takes label imbalances into account. And then is ROC-AUC. ROC is a probability curve and AUC represents degree or measure of separability. Besides these, we'll consider the class weight in the further model building. So feature engineering. For the text feature first, we take the bag of words BOW strategy. The idea of BOW is to place all the words to a bucket with ignoring the original occurrence order. Second, we use TF-IDF to convert the text into vectors. So what is TF? TF represents term frequency, which is the number of times a word appears in a document divided by the total number of words in the document. And then IDF, inverse data frequency, which determines the weight of rare words across all documents. And then TF-IDF is calculated by the multiplication of TF and IDF. TF-IDF reflects the importance of a word within a comment. We also need other features. Review length. When customers have strong emotion, they're more likely to share their opinions, so we add this feature review length. The second one is number of exclamation marks. Obviously, this is a good measure of the degree of emotions. Now, I'd like to give you an example to elaborate on the TF-IDF. I'll use the nonce common in the dataset as the example. As we can see here, after text pre-processing, only adjective and verbs are left. And the first step, each word in the dataset is assigned to an index. For example, the word tat. Its index is 6383. And then the second step, we need to construct a vector to record the occurrence frequency for words left. And the third step, we need to construct a vector to record TF-IDF values in the comment. The words that do not occur in the comment are assigned to 0 TF-IDF values. And lastly, we need to convert the vector into the matrix form. The words with 0 TF-IDF values will be filled with 0 in the matrix. Here are the models we're going to use: SVM, logistic regression, random forest, and AdaBoost. Let's check out the results. For recommended, we can see that the micro AUC score of all these four methods are over 0.8. Among these four methods, SVM has the best performance. So we give the details SVM here: confusion matrix, classification report, and ROC curve. Now the result for rating. Among these four models, SVM still has the best performance, which has micro AUC score of 0.9. So we gave the details SVM here: the confusion matrix, classification report, and the ROC curve. Section 5. Sentiment analysis with deep learning models. Here I'd like to introduce some deep learning models. The first one is recurrent neural networks, known as RNN. As the name implies, the stating RNN is recurrent. This feature is important for NLP because the network can take the dependency among words into consideration without destroying the original sentence structure. The second one is long short-term memory, known as LSTM. Actually, this is a modification of RNN with adding the input gate, output gate, and forget gate. LSTM can overcome the problem of vanishing gradients resurface in typical RNN. And the third one is the model we use for this project, bidirectional LSTM, known as BiLSTM. It's a modification of LSTM. With both forward and backward layers, this model can learn from both past and future context to provide better performance in NLP. So text preprocessing for BiLSTM. Well, similarly, we need to remove punctuation, stop words, and also we need to do stemming, just like machine learning. In addition, since we use carrots to build our LSTM model, the embedding layer is needed. We set the input dimension of the embedding layer to 100, which means that all the words will be represented by a vector of 100 dimensions. After text cleansing, we use tokenizer to vectorize our review corpus and get our vocabulary size, which is 10,057. We then set the max length to 70 and get the pet features. We tried 3 structures in this model. And now let's check out the results. Firstly, for recommended, we can see that the 2-layer by LSTM has the best performance. So we gave the details of it. Confusion matrix, classification report, and ROC curve. Now, result for rating, we can see that these 3 structures have nearly the same performance. However, the computing cost for structure 3 is really high, so we'll only give the detailed information for structure 2. Confusion matrix, classification report, and ROC curve. Section 6. Comparison between traditional machine learning and deep learning models. From the results, we can see that deep learning models provide much better performance than machine learning models. What is the reason behind this? The first reason is the bag-of-word strategy used in machine learning destroys the original structure of the sentences. The second one is the TF-IDF matrix used in machine learning cannot represent the original dependency among words. However, in deep learning, the by LSTM model can take dependency among words into consideration. So this is the reason why deep learning provides better performance. We also notice an interesting fact from the confusion matrices. Most of the classification errors happen in the neutral reviews. Why? We think the reason is neutral reviews contain both positive and negative words. Let's check out an example here. Neutral reviews contain words like nice from positive reviews and also cheap from negative reviews. So this is the reason why most of the error occur in neutral reviews. Section 7. Further analysis and improvement. For further analysis, we try to use LSTM model to generate common text by learning the feature from the current dataset. However, the result is quite poor. For further improvement, first, we can do more data cleansing work on the original training texts. Second, we can try more professional sentiment analysis libraries like TextBlob and Stanford Core NLP to improve our classification models. So, thank you for watching and thank you very much.